All right, Heather, thank you so much for asking questions. So I'm going to do several problems. I'm going to just send you the videos. So 6.6, number 6F, that's the first one you asked about. Okay, so when I look at this particular problem, my first thing I want to do is I want to get everything in terms of prime numbers. So the numerator is okay because I have 2 to the 8th, and I have 3 cubed, and I have 5 cubed. Okay, now when I look at the denominator of that, I have 6. So 6 is 2 times 3, and I want that raised to the third power, and I want 4, oops, I don't want 4, because 4 is not a prime number. I want to rewrite 4 as 2 times 2 to the third power, that's right. Okay, so that is the numerator of our whole problem. And I think for simplicity, let's just go ahead and go across here and simplify that. So that's 2, 8, 3 cubed, 5 cubed, 2 cubed, 3 squared. I'm sorry, 3 cubed. I don't know what I'm saying. Okay, now this is 2 times 2, so that's the same as 2 squared. So 2 squared to the third is 2 to the sixth. Okay, I'm going to leave that alone for right now. Now, in the denominator, so I have the big fraction line, in the denominator I have 10 squared, so that's 2 times 5 squared, and 6 is still 2 times 3 squared, and I want to divide that by 15, which is 3 times 5, times 3 squared, 2 squared. Okay, so let's go ahead and let's simplify that now. So I have 2 squared, sorry, I'm thinking ahead while I'm writing. 2 squared, 5 squared, 2 squared, 3 squared, divided by 3 times 5 times 3 squared times 2 squared. Okay, so now I'm going to make this so I know that this is the big fraction line. Okay, so now let's simplify the numerator. Okay, let's do that first. So on this numerator, let's look at like terms. So on the numerator, I have 2 to the 8th, and in the bottom, I have 2 to the 6th and 2 to the 3rd. So those are, the bases are the same, so I go ahead and add those together. So on the numerator, I have 2 to the 8th, and in the denominator, I have 2 to the 9th. Okay, so to show you what I'm thinking, I have 2 to the 8th divided by 2 to the 9th. Now when we simplify that, we always take the smaller number to the larger number and subtract our exponents. So if you remember back in that section, if I had something like 2 to the 4th divided by 2 cubed, they just cancel out. So I could take 4 minus 3 and get that. Okay, so here I'm going to take 9 minus 8. So I have 2 in the denominator of my numerator. Now here I have 3 cubed and 3 cubed. Well, 3 cubed divided by 3 cubed is 1, so that totally goes away. And in the numerator, I don't have anything to put the 5 with, so I have 5 cubed. Okay, so now let's look at the denominator. I have 2 squared in the numerator, so that's 2 to the 4th. And in the denominator, I have 2 squared. So that's going to leave me a 2 squared by subtraction in the numerator of the denominator. Okay, so I've used all of those. Now, what do you think 3 is going to be? I've got 3 squared and 3 squared, so I know those cancel out, and I have a 3 left. And then I have 5 squared and 5, so that means I have a 5 left. Nice. Oops. Okay, hopefully you caught this. That 3 is really in the denominator, right? Because I have 3 squared and 3 squared right here. And this guy is still in the denominator, so I need to leave him there. Okay, so I have 5 cubed over 2. and 2 squared times 5 over 3. So let's go to the next page. 5 cubed over 2 times, or divided by, 2 squared 5, 2 squared times 5 over 3. So now, we know from the work we've done, because this book does a great job of developing the idea of taking whatever's in the denominator and flipping it over and multiplying. Okay, so I have 5 cubed and 5, so that will be 5 squared. I have 2 and 2 squared, so that will be 2 cubed. And then I've got this 3 hanging out here by himself. So this is my answer, and I'm totally okay if you leave it like that. I think it's easier than multiplying the whole thing out. Okay? All right, so that's the first one.